Hello class, welcome to today's lesson. And today we're going to talk about the following concepts: average speed and instantaneous speed, and average velocity and instantaneous velocity. What I want you to understand, guys, in this lesson is just the difference, the conceptual difference between this average speed and instantaneous speed, and the same for velocity. I want you to understand what's the difference between this adjective and this other adjective, whether in regards to speed or velocity. So let's first read more or less, the what we mean by average and instantaneous in the context of, of kinematics. So average in this context means the overall behavior of the motion, as a whole. And that's what average means, right? In everyday life. And instantaneous means the behavior of the motion at a precise instant in time. So this is just the overall behavior of the motion, and this is the behavior of the motion at a precise instant in time. Okay, let me explain to you what this means, because maybe words don't help us very much, right? So I have two examples here, guys. I'm gonna walk you through two examples, example one and example two. Don't ask me why I put them like so. It's the same. So example one, I want you to observe this, guys. This represents a road. This is a road, uh, and in a moment, I'm gonna move the pencil. Try to think of this pencil that I'm moving right now. This is gonna be our particle, the pencil itself. It's gonna be the particle that is gonna travel from this initial position or this initial point in the motion to this final point in the motion. This is a road, and this part in here and this part in here represent kind of like a very rough surface. Like there is a lot of rocks and maybe grass, and you understand what I mean. So this is a very rough part of the road, and this blue segment represents a very smooth part of the road. Think of, I don't know, uh, like your normal standard floor in a house or something like that, something that is quite smooth. Okay, so here we go. The pencil is going to move in this way. Since this is a very rough surface, all of these two, what you expect is that the pencil will move slower in here, in these two places, and in here it's going to move faster. What you expect is more or less this behavior. Pay attention. Can you see? I'm going to repeat that two more times. One more time. There you go. So that's the motion that this particle is undergoing. And what we observe, guys, is like I told you, the pencil is moving slowly in these two places, in these brown places, and fast in this blue segment. Okay, now let's talk about what we understand as average. Let's consider first speed. Let's talk about speed first. Let's understand the difference between average speed and instantaneous speed. What is the difference between these two? Okay, if you remember, guys, from the previous lesson, I told you that the speed was defined as the distance traveled over the amount of time that it takes to travel that distance, right? That's all I said. This was the definition of speed. Okay, now you must understand the following, guys. What I was talking about when I gave this definition to you, what I was talking about was this. the average speed. When I made this definition for you, and when you read this definition from the book, what that definition was talking about was specifically the average speed. The average speed is the whole distance traveled divided by the time. So for example, in this case in which I once again repeat the motion slowly, 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 and then faster, and then slow, 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 slow motion. So let's get the average speed for this particular motion. Let's get the average speed. And remember, this is the definition of average speed, the one I already told you about. And it's just the distance traveled divided by the time. How much distance did the pencil travel? 2 meters plus 6 meters plus 2 meters. That's going to be a total of 10 meters from the initial to the final point. And in here, I'm being told that the time of motion is 5 seconds. So in order to get the average speed, all I need to do is divide the total distance traveled over the total time of the motion, and we get 2 meters per second, and that's the average speed. So basically, what we calculated in the previous problems was the average speed in all cases. In all cases, 2 meters per second, that's it. We're done. What does this mean? How can we interpret this number, 2 meters per second, this quantity? Well, that is as an overall motion, or as an average, okay, that was the speed of the pencil throughout this whole motion from initial point to final point. This was the average speed. What you need to understand is this, guys. The motion of the pencil throughout this segment from I to F may not be this. Okay, why do I say this? Because, for example, in these two parts of the road, the pencil is traveling very slowly, and here is traveling very fast. Okay, so you must not think that at any particular point in this motion, the pencil was traveling at this speed. This is just the overall behavior, or the average speed of the motion. But in this part, in these parts, in this and this, the speed must have been slower than 2 meters per second. Let's say 1 meter per second. Let's just suppose. And in here, in this part, it must have been greater than 2 meters per second. For example, we might say 5 meters per second. Okay, so first it's traveling very slowly, and then very fast, and then very slowly. You see, so that as an overall or average behavior, we get 2 meters per second. But what we had in here was a velocity of 1 meter per second, and then in here a velocity of 5 meters per second, and in here again 1 meter per second. And when we consider the speed at a specific time in the motion, for example, right here, if I ask myself, at what speed is the pencil going right there at this point, then what I'm considering is the instantaneous speed. The instantaneous speed is when you ask, what is the speed of the particle at a precise instant in time? Or for example, right there at that point, when the pencil crossed that point, what was the speed instantaneously of the pencil at this point? And so on. So that is the difference between this concept, guys, average speed and instantaneous speed. The average is just the overall behavior, and the instantaneous speed is the speed that the particle has at a specific point in time. And this one, the instantaneous speed, can be very difficult to calculate. It's much difficult. The average speed is very easy. It's just what we have been doing. Like, okay, get me the total distance traveled and get me the total time. I divide them, and that's it. That's the average speed. It's something very easy to understand, because we don't have to deal with the details of how the particle moved from I to F. Like, we don't care if at some point or at some segment of that motion the particle sped up, etc. We don't care. It's just an average. So that is the difference, guys. Let me do the same thing for you here. Look at this. We have the same particle going from I to F, and we have these two segments. This is 1 kilometer, this is 2 kilometers. All right, so pay attention. This is how I'm gonna move the particle. Ready, go. One more time. Ready, go. Can you see that? Okay, so if somebody asked me, calculate the average speed for this motion, the one that you just saw, the average speed. All I need to do is get the distance traveled and divide it by the time of the motion. Okay, what was the distance traveled? Well, the particle, as you watched, first traveled 1 kilometer in this direction and then 2 kilometers upwards. So the total distance traveled is 3 kilometers, and I'm being told that the time of motion is 1 hour. Therefore, the average speed is 3 kilometers per hour. That is the average speed. That's what we have been doing in the previous problems, and I'm done. But you must realize, guys, that if you observed carefully the motion, I did this first very slowly and then lightning fast. Again, very slowly and then very fast. Therefore, even though we can say that the average speed is 3 kilometers per hour, and that is perfectly okay, you need to understand that the instantaneous speed in these points of the motion, like right here or right here, the instantaneous speed in this part of the motion is lower than the instantaneous speed that the particle had maybe at these 2 points through the motion. Because in this part of the motion, guys, the particle was moving very slowly, very slowly, very slowly. So the instantaneous speed is very slow, and then it goes very fast. So when the pencil crosses these points in time, or these points in the motion, the instantaneous speed must have been very high. So this is high instantaneous speed, and this is low instantaneous speed. But when we get the average speed, we don't care about those details. We just get the total distance, the total time, and we're done. That is the difference. Let me show you two animations so you can uh, further understand the concept. Okay, look at this object, guys. It's a box or a mass. Let's call it a mass. Ignore completely these arrows. These arrows don't mean anything for us. Ignore them completely. We just have a surface. We have two springs, dos resortes, and this blue mass is connected to both springs. And watch the motion, guys. I want you to observe the motion. Just take a feeling of how the mass is moving. Try to imagine that you are, uh, I don't know, you are on top of this mass. You're sitting down there. You're a small person. You're sitting on the top of this mass, and get a feeling for the motion. Okay, so question: At what point in this surface, like let's call this point 1, point 2, and point 3. At what point is the instantaneous speed greater? Okay, think about that. At what point, either 1 or 2 or 3, at what point is the instantaneous speed the greatest, and at what point is the instantaneous speed the lowest? Try to answer that question for yourself. I'm going to ask you in a moment. I'm going to repeat the question. This is point 1, point 2, and point 3 of the surface. At what point is the instantaneous speed the greatest, and at what point, or at what points, is the instantaneous speed the lowest? Okay, let's consider that. Now let's look at this other animation. By the way, I'm gonna ask for your answers in a moment. Look at this, guys. Same thing. Observe try to analyze all of this: the distance, the time. Take a look at how the traffic lights work and the motion of the car. I'm gonna give you some time to analyze the whole thing. Okay. Now, now that you have observed that GIF, um, this animation, let me ask you some things. If I wanted you to calculate the average speed of this car, what would you do? The average speed, just the average speed. If I wanted that, what I would have to do if I wanted to calculate the average speed is just, okay, even though the car may be moving very with a very complex motion throughout the whole segment, I don't care. I just care about the distance traveled, which is 5 miles. So it's 5 miles. And I only care about the time that it takes to go from the initial point to the final point, which is 0.2 hours. You see? Okay, 0.2 hours. Then I divide this over this, and I'm gonna get 25 miles per hour. You see how it works? That's it. That's the average speed. Now, does that mean, guys, does that mean that the car is always traveling with this speed throughout this motion? No, that's not what it means. This is just the overall behavior of the car's motion going from 0 to 5. As you can observe, the car is making two stops, complete stops. Look at this red sign. It stops. It stops. You see? It stops here. It stops here, and then it goes very fast in this motion. In this part of the road, it goes very fast. Look. Can you see? So even though the average speed is this, what we must understand is that at some points in the road, the instantaneous speed is different from this. At this point in the road, the instantaneous speed is 0. Can you see? Because the car momentarily stopped. At this point, the instantaneous speed is 0. At this point, the instantaneous speed is also 0. And over here, since the car is going very fast, right there, can you see? The instantaneous speed must be greater than 25. I don't know, let's say 35 miles per hour or something like that. If we wanted to know exactly the instantaneous speed, we would have to take a look at the speedometer of the car. You know, the thing that tells you how fast you're going. You must have seen those in the car. It's like 20 kilometers, 80 kilometers, and you have a, a needle that tells you how fast you're going. Okay, so that is the difference, guys. That is conceptually the difference. I wanted you to understand the difference. And in most of the times, we're going to be just considering the average speed and the average velocity. By the way, I never spoke anything about average and instantaneous velocity. It is the same idea. If you understand the concept behind average speed and instantaneous speed, then translate those concepts onto velocity, and it's pretty much the same. Okay, so let me go back with you guys and see if you have any questions.